This is experiment E03, testing of polyphase induction motors including single phasing conditions. After watching this video, you should be able to derive a single phase equivalent circuit model for a three-phase induction motor, determine the distribution of losses in a squirrel cage induction motor from test results, and examine the currents in a delta connected motor under single phasing conditions. The equipment we need for this experiment includes a three-phase induction motor, 2 watt meters, a power meter, a three-phase variac, a 3-pole switch, and an MCB. The equipment you are using will be energized at up to 220 volts. Some of the equipment is delicate, expensive, and easily damaged if misused. It is your responsibility to ensure that your circuits are correctly connected and have been verified to be correct by your supervisor before energizing the circuits. Before changing the connections of the equipment, you must switch off and isolate the power source. You must take care to avoid entanglement of connecting cables, clothes, or your hair with the motor's rotating parts. Finally, always keep the protection guard on the rotor shaft. Stage 1 aims to ensure that the delta connection for the motor is correct and to check that the motor can be operated safely. Your first task is to record the motor nameplate data. Note that the rated phase voltage of the motor is 220 volts and the rated phase current of the motor is 3.46 amps. Then, connect the circuit as shown in figure 1, which shows the connection of the motor and the 2 watt meters using the 2 watt meter connection. It is used to measure the total electric power supplied to the motor's delta connected three-phase winding. Now let's take a close look at the delta connection. There are 6 terminals on the motor, 2 for each of the red, yellow and blue phases. We name the upper 3 terminals R1, Y1 and B1, and the lower 3 terminals R2, Y2 and B2. For the delta connection, we use a cable to connect the R1 and B2 terminals, another cable to connect the B1 and Y2 terminals, and a third cable to connect the Y1 and R2 terminals. The circuit should look like the delta connection shown in figure 1. Now complete the remaining connections. Remember that you need to set 0 on the 2 watt meters. After you have completed the connections, ask your supervisor to check the circuit for you before energizing it. Now, turn on the power switches, turn the variac up gradually with both hands to slowly raise the voltage to about 25 or 30 volts. Carrying out the voltage change slowly helps to reduce current surges as the motor starts. It is important to remember that the winding voltage must not exceed the rated value of 220 volts. Next, check whether balance conditions exist by measuring line currents IR, IY and IB, and winding currents IRB, IBY and IYR, using the current clamp connected to the power meter. In stage 2, you will conduct the no-load tests for the motor when it is delta connected. First, apply a voltage of 110% of the rated value 220 volts, i.e. 242 volts. Then, record the line currents IR, IY and IB from the readings of the current clamp meter. record the input power WA and WB from the readings of the 2 watt meters. If you see the red over-range indicator lamps on the watt meters light up, adjust the knobs to select more appropriate ranges of current and voltage. Note that the reading of WB is negative. Press the reverse button to obtain the readings. Record the voltages VRB, VBY and VYR from the readings of the power meters. Take the average current in each line or winding, since the motor is unlikely to be balanced. Having recorded a set of data, reduce the voltage by 20 volts, then record another set of data. Do the same procedures until the motor stalls or stops rotating. After collecting all the data, turn the variac to 0 gradually using both hands. Then turn off the power switches one by one. In stage 3, you will conduct the single phasing no-load tests in the delta connected motor. First, connect the MCB as shown in figure 2. Ensure that the MCB is closed, i.e. it is in the on position. Switch on the power source. Turn the variac up so that the voltage reaches its rated value of 220 volts. With the MCB in its closed condition, measure and record the normal 3-phase no-load line currents IR, IY and IB, and the winding currents IRB, IBY and IYR. Also record the input power WA and WB from the 2 watt meters. With the motor still rotating, open the MCB, then measure and record all parameter values again. After collecting all the data, gradually turn the variac down to 0. Switch off the power source and close the MCB. In the final stage, you will conduct the locked rotor tests. These tests must be conducted quickly to avoid any damage to the motor windings. Before energizing the circuit, lock the rotor shaft securely. Ask your supervisor to check it for you. Put the protection guard on the lock shaft and ensure that the MCB is closed. Check the rated current of the motor from its nameplate. Now, turn the variac up until the line current reaches the rated current of the motor. You may monitor the line current of any phase because they should be similar in magnitude. Record the locked motor line currents IR, IY and IB and the winding currents IRB, IBY and IYR from the readings of the current clamp and the input powers WA and WB from the readings of the 2 watt meters. Open the MCB and record the values of the previous currents and power again. Now we have finished the locked rotor test. After collecting all the data, gradually turn the variac to 0 using both hands. Switch off the power source, unlock the motor shaft and tidy up the equipment. This is the end of the experiment.